wanted it to do, but it was really slow. And we just couldn't, you know, the saying, speed kills, is true in orthopedic robotics, except it's slow speed kills. Like if you have a system that's gonna double your OR time, you can forget it. So we tried everything we could to make a rotary tool work. We just couldn't make it go fast enough. So we switched to a saw. The problem with a saw is that the human hand and eye is really, really good at doing certain things, avoiding soft tissue, dampening, vibration, cutting efficiently. Like I could give an intern a saw, and they're pretty intuitive about making micro adjustments to make the saw cut efficiently. So what we had to do was make a robot do all those things that a human does, and I had to translate that to the engineers and say, well, I need the saw to kind of peck at the bone. And so we had to innovate on the system to resist its weaknesses, like vibration. We had to put dampeners in the blade. We had to orient the end effector so that it wouldn't upset the robot with vibration. We had to change the weight distribution of the saw and optimize the oscillation rate so that it wouldn't vibrate the whole system too much. We had to figure out what was the optimal oscillation speed. And we were able to innovate ways to really make the saw efficient. We upped the horsepower of the motor, and we have current demand that detects when the robot is hitting really hard bone, and it'll speed up through soft bone and slow down in hard bone. And so this is how we've kind of been able to get a saw to do automated cutting safely and effectively. I'm going to skip my last couple of slides, but I do want to, because we're going to have a lot of AI talks, I want to recommend custom implants is another thing you can do with a robot. This is a